Okay, so we've talked about having ones and zeros everywhere. So row echelon form is where you have the main diagonal are ones and everything under it are zeros. That is row echelon form. We are also going to just go to reduced row echelon form. So regardless of what your directions say, everyone listen to me. Regardless of what your directions say, you are going to go to reduced row echelon form. You are going to use, that is the zeros everywhere, top and bottom. Okay, so
Do you want us to write those?
We really need to write that?
This is, no, you need to understand. I would draw a picture.
Can you
I would
show
draw a
us
picture.
to draw?
Yes, just a second. So row echelon form looks like this. Not like that. Looks like this. Those are numbers. Got it? Those blanks are numbers. That's what row echelon form looks like with Gaussian elimination. We are going to take it a step further and do reduced row echelon form. Otherwise known reduced. Actually, I'm going to write down here.
Do you want us to write numbers in there or just do the dash?
I would just do the dash because it doesn't matter what they are. Does that make sense? Okay, reduced row echelon form is what we're going to go do. And that's ones on the diagonal still, but what's everywhere else now?
Zeros.
Zeros. Except for your answers. Because remember, if I do that, then I know X is this, Y is this, and Z is this, correct?
Yeah.
Yes. Okay, so no matter what your directions say, you are going to do reduced row echelon form.
We're just trying to get it to that. That's all
Yes.
we're doing today?
That's what we're doing. That's what we're doing for the next 4 days.
Okay, awesome.
Okay. So, if I'm working on my homework and I get so far and I get stuck, I stop, go on to the next one. Got it? I want to understand what I'm saying. Come back. If I do and I'm frustrated, come back. You guys will know the answers. Tomorrow I'm going to show you how to make your calculator tell you the answer so you know the answer even to the evens. I don't care about the answer. I care about how you get there. Got it? This is a procedural thing we're learning. So, what are we looking for no matter what it says?
Reduced.
Reduced or echelon form. Okay? And now I think today it says use Gaussian elimination, so that would just be row echelon form. Okay? And then you'd have to do back substitution. But your answers are going to be the same regardless, correct? So if you get it to the reduced part, you got half of it. But I want you to keep going. So which one of these is row echelon form? Is A?
Yeah.
Oh, yes.
Yes. We got ones on the main diagonal, yes?
Yes.
And zeros underneath it.
Yes.
So this is an R-E-F. What's R-E-F stand for?
Row echelon form.
What do you think reduced row echelon form?
R-R-E-F.
R-R-E-F. I don't know. Okay, is C?
No.
No?
No, because the ones that are not
No,
in the middle.
Because the main diagonal would be right here, correct?
Yeah.
And they're not there, are they? Okay?
No.
No, not even close, right? So no, no, no.
Yeah.
That one's R-R-E-F.
Yeah, that one's R-R-E-F.
No, it's
Oh,
not.
wait.
'cause
Well,
you got a
if
negative
this
two
is-
and one.
Okay, then.
Okay, actually, this one would be reduced row echelon form.
There's
Now,
no-
let's talk about it. The main diagonal starts here, yes?
Uh-huh.
Okay, and these are my solutions.
Yeah.
So do I have ones on the main diagonal?
Yeah.
What do you notice about how many variables would be in this matrix? X,
3.
Y, Z, yes? How many equations do I have?
4.
4.
What?
Now,
Oh,
I
what
told
about
you
zero?
to have a unique solution. That means one solution, yes? If there's 3 variables, how many equations do there have to be? 3. How many equations did I give you? 4. This is what it would look like.
There's a W.
Nope. This would be infinitely many solutions. And anytime that 0 equals 0, that would be infinitely many solutions, okay?
There's
And
the
then
whole
we're
thing.
gonna have another step after that, but just not today, okay? When you get to infinitely many solutions, there is another step you have to do, and we will go over that tomorrow because you have an infinitely many solutions one in your answers today, and we're gonna go to that next step tomorrow to show you what you do after you get there. Yes.
So if it's like that on the bottom,
Mhm.
0, 0, 0, 0, the whole thing is just infinitely many.
Yes.
That's all it is.
Yes.
But then we'll do more steps.
Yes.
Got
Okay. What about this one? F.
it.
None.
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 It's not, right?
The main-
Isn't it?
the-
Because
Ben.
this is my main diagonal, yes?
Yes.
And I do not have ones there, do I?
Nope.
Nope.
Those are zeros.
Those are zeros. Thank you. I was
Yeah.
confused.
You're welcome.
Okay. That went backwards.
That's the
Okay.
code.
So this is reduced row echelon form. You should have already written it down. But this is what we're going towards. Okay?
So Ben-
The row echelon form is accomplished through Gaussian elimination. Okay? Reduced row echelon form is accomplished through Gauss-Jordan elimination. So our main goal is, I used to teach this in like 4 steps, and I'm like, no, why am I doing that? Let's just go for the gold.
She's throwing it at you, huh?
I know, I missed. Let's just go for the gold, do what we're supposed to be doing instead of doing all these steps. Okay? So we are going to be performing Gauss-Jordan elimination to get it in what form?
Reduce.
Reduced row echelon form. People go, oh, I gotta do reduced row echelon form. Reduced row echelon form is not a procedure. It is an answer. It's the form your answer is in. Okay? Like, I don't do y equals mx plus b, do I? That's the equation of a line. It's a different form. It's not a procedure. Okay, so use Gaussian / Gauss-Jordan elimination. We are only doing Gauss-Jordan elimination. That's what we are doing. Got it?
Yeah.
So we need to write this system of equation in what? What kind of a matrix?
Reduced row.
No, that's what we're going to get to at the end.
Algo.
Augmented.
Yeah, I didn't know how to say it.
You said
Okay, I need to put this into an augmented matrix,
It's
correct?
gonna be a 2x2.
It's going to be a 2 by 2.
2x3 actually, because it ain't.
Well, yeah, but your coefficient matrix is 2 by 2.
Yeah.
Okay.
That's what I meant. 2, 6, 16 over 2.
This part was easy. I like it.
Okay, so my goal is to get this. That's my goal. Yes?
Yeah.
Okay? Because that's what it would look like in a 2 by 2, isn't it?
Yeah.
And what it would look like in a 4 by 4. You guys get that. 1's on the main diagonal, 0's everywhere else. That's just it. So, if I want to eliminate anything in column 1, I look at row what? 1. My procedures I can do, I can switch a row. I can multiply a row by a non-zero number. I can combine multiples of rows together. Those are what I can do, correct? Now, switching rows. Yesterday I warned against using the books techniques, yes? And I will tell you that again. Sometimes they're good, sometimes they're way over your head and you're just doing it and not know why you're doing it. I would only switch a row if I had a way to get it all 1s, or 1 is a leading coefficient, okay? Or if it was the smaller numbers. Why would I want smaller numbers in row 1 if I possibly could?
Because then you can multiply them to get the bigger.
Yeah, I can multiply to get to the bigger numbers on the bottom, and I wouldn't have to be doing huge numbers, right?
Yeah.
Well, in this case, I had 2 and 2, so switching rows would not do me any good, would it?
Multiply by.
Okay, so there are 2 different things we could do.
Oh, wait, that makes sense.
Evan,
Can you divide the top by a half?
I can't divide.
Well, no, times by a half.
Yes, why would you multiply the top row, row 1, so we're going to call row 1 2, row 1 by half. Why do you want to do that, Evan?
Because it makes the 2 a 1. Where
It makes the 2 a 1,
They're
and
all even,
everything else is even. Now, if I had, would I do a half of row 2?
No.
No, I don't want 7 halves, do you?
No.
No. Okay, so my first step then is going to be 1/2 R1. Please leave a gap between your matrices so you're not blending them in. Make sure you wrote it down right, you didn't miss any negatives. Take those few seconds to do that stuff. Yes?
Would you take 16 by half too?
Yes, I would take 16 by half. Evidently, I didn't feel the need to do that. That's why you stop and make sure you did it right. Because if I wouldn't have stopped to say, did I do it right, I would have had the wrong answer, correct? You can do the procedure the right way, the whole thing down, and get the wrong answer if you don't multiply right or all that. Okay, yes?
And then once you do -2r1 plus row 2
Why are you doing -2r1 plus row 2?
to get the 2 to a 0.
Yes. So -2r1 plus r2. Do it. Did you get -3, -9? Okay. Whoever said, oh wait, did you figure out what you did wrong?
No. So we're taking -2
R1
R1 R1
and adding it to row 2. So this would be -2, so this would be -2 and 2 is 0.
Yeah.
-2 and 3 is -6
Mhm.
and 3 is -3.
Okay.
-2 and 8 is -16 and 7 is -9. If you need little numbers over here, do it. Got it? But it can't be in your matrix. And I would suggest you don't put it on the left-hand side, put it on the right.
How did you get -3? Sorry.
-2 times 3 is -6 plus 3 is -3.
Oh, yeah, I went the wrong way.
Okay.
That's fine.
Now, this is my goal. Always have to keep that in my head.
Oh. What?
Well, go ahead and say what you're going to say.
I was gonna say what to do.
What are you going to
Would you add them?
Okay.
One
Now,
third.
he's just saying combine these two rows. Yes? The video can't see it. He's just saying take R2 plus R1. Now, anybody else? Did anyone want to do a -1/3 of R2? Could I?
wanted to do.
Yeah.
Okay. I could do that, but then to clear this 3, I'd have to multiply it by 3. Does that make sense? You could do that, Maddie, but then you would have to kind of undo it. So since these match, anybody else with me just going for what Connor said? Okay. So row 2 plus row 1. I have to write row 1 second because that is the one that's changing. And I count off for that, guys. If you write row 1 plus row 2, which one is changing?
Row 2.
Row 2. And we're changing row 1. You got it done yet? So I think you should get 1, 0, -1, 0, -3, -9. Yes?
Mhm.
Now, Maddie, we can do your what?
1/3 on the bottom. -1/3.
-1/3. Why -1/3?
To get it to positive.
Okay, so -1/3 R2. Did you get 1 and 3? So what's my answer? -1. It should be +3. How
So
can
that's how we would leave our answer.
Well, that is our answer, or an ordered
Not
pair.
x equals.
No, because it's an ordered pair. If it's an ordered pair, the assumption is this is x, y, correct?
What do you mean it's an ordered pair?
It's a coordinate on a graph
So how do we know that?
because we have a system of equations, and the solution of the system of equations is where they cross.
Okay.
Now, Now I'm hoping we get to the 3x3s, but if the 3x3 is any different than this,
No.
no, we just go, we do column 1, then column 2, then we go back up, just like we just did. Okay, what do I do first?
Make it
Set it up
into
into
a
a matrix.
What kind of matrix? Augmented.
This one gonna be easy because they're lots of five.
We can multiply the top row by one fifth.
Okay, why do you want to multiply
Because we'll get all of those to one.
all those to 1? Okay? If I can do that, do it. But if I can't do it, I just deal with my numbers, right? I'm going to tell you the textbook will do some funky thing like add 2 rows, then multiply by a third, and like 6 steps just to get a 1 there. If you can't get a 1 by doing something really easy, guys, don't worry about it. Got it? Because you're going to get lost in all those steps. Like I said, they do these problems like somebody who's done them for 30 years, and you're doing them for 4 days. So don't start doing this acrobatics. You guys got done yet?
No. Negative 1/5 or just 1/5?
Well, which one?
Negative 1/5.
Whichever one you do is gonna change.
We want a positive 1 there when we're done,
You want a
yes?
positive one in the
Yeah, so
front.
just
So,
1/5.
Just
Positive.
1/5. Now, if row 2 was divisible by all one thing, would I want to do that right now also? Yeah, and I could just, and the whole point is to get numbers smaller, correct? You got it, your answer now?
Not though.
So you got 1, negative 1.
I didn't know if we wanted to do a negative 1/5 because there was 2 negative ones. But,
Yeah, but we want that very first one to be a positive 1.
Do you always want to solve like the first row first?
Not always, because like I said, let's say if row 2, like if it was negative 2, negative 3, 7 in my first row, and I couldn't get something to be 1, I would just leave it till the end. Because then I can take, like that really bad problem, we can take it by 1, whatever, when we're done.
Is that where you can flip it upside? Like,
Yeah, you
the
could
row?
flip them. Like if I had written these two opposite, we would have flipped it. Okay, so now what?
row
What?
row 1 by 2.
Okay, the whole goal, yes, you're right. But the whole goal is to get this to be a 0. Is that going to happen every time? You want to zero out column 1, then column 2, then column 3, then back to 2. That big circle that we showed you yesterday, right? Okay, so Maddie, what was that again?
2R1 plus R2.
Okay, so do it. Now I think you should have got negative 5, 5. Get negative 5, 5? Okay. So you guys are my check too. Now this one over here we just combined next, correct? Why did we just combine next?
Because we had the 3.
We had 3 and 3, right? Do I have 3 and 3 here?
No.
Or 5 and
you
5
need to
here?
multiply row 3 by negative 1/5.
I'm going to take row 3 by negative 1/5 because they don't. Row 2, yes. I'm always row 3. I mean, the bottom row is always row 3 to me. We're going to do that because they don't match anyway, do they? Okay, and so to get my number smaller, so negative 1/5 because I want it to be a positive anyway, right? Are you lining up your augmented lines? Well, make sure you work on that. Okay, did you get 1, negative 1?
Yeah.
Yes. Okay, so I got 0 column 1. Now I need to go in 0 column. 2.
Now you can combine them.
So now all I have to do is what?
Combine them.
Add row
Add row 2 to add
row
row
2
1.
plus row 1.
Okay,
Because otherwise you get the bottom one.
and my solution is what?
Negative 1, 1, negative 1.
Negative 2, negative
Negative 2, negative 1.
Oops.
Because a -1 plus a -1 is a -2.
I'm so happy.
So 2 by 2s are fairly easy and quick, yes?
Thanks, I felt
Now, I am not guaranteeing that everything will be whole numbers, but you don't want to give your self fractions till the very end, right? Okay,
No.
Yeah.
Are you
No
kidding me?
heck. Wait,
Let's
I
do
have
it.
to like,
Rest-
you can do, I know how to do this.
You
can
have to multiply
it
it by 10.
No, 100.
Did you hear? Everyone just goes.
10 or 100?
100.
100.
The
I
top
don't
one's
know.
100.
I don't know
The most decimal places, yes?
100.
Which would be the 100. Why do I multiply everything by 100?
Because then we'll get them to whole numbers.
Then I can get them to whole numbers. Could I multiply one equation by 100 and the other equation by 10 if it fit?
Yeah.
Yeah.
But that's not how
So,
it
but that's not gonna work. So we're gonna multiply both by what?
100.
So
100.
100 R1.
So we're 100 R1
Yep.
and 100
R2.
R2. Remember, if I don't like them, get rid of them. Could I do that with fractions as well? If I had fractions, could I just multiply by the least common denominator and get rid of them?
Yeah.
Better, bigger numbers than fractions, right? Okay, so I think we get 1, -3. That's a weird negative. And 5. And -2. And 6.
And 100. Negative
And 10.
Negative 10.
We're multiplying.
What did you write on the
Oh,
top?
I didn't see the point sign.
100 R1. My O got 100 R1. And 100 R2. Now, do I have some nice numbers?
Yes.
Yep.
I can deal with it.
If row 2 was above row 1, you'd switch them first, wouldn't you?
Oh,
Because that 1. Just keep bringing that up because they're not always going to be a 1 up there. All their examples seem to be. Okay, now do we just kind of go?
Yeah.
Okay, so do your first step. I'll give you a minute, then I'll do my first step. And if you get your first step done before I do, go.
Wait. No. I was gonna say, uh-oh.
Uh-oh. Is that an uh-oh?
Yes.
Yeah.
Because
This is infinitely many.
This is infinitely many. Okay, and I'm going to go ahead and just show you what we do. We say infinitely many. Now, we have to get this closest to Gauss-Jordan, reduced row echelon form as possible before we're done.
So we can
Okay.
get rid of the negative.
Now, can I though?
no.
In order to get rid of this
You
negative
don't
3,
think
I
negative.
have to have something there where that 0 is. Can I? No.
You think-
If I had a 3 by 3, there could be some more stuff I could do before I say I'm done, but I can't. So my two variables are x and y, correct?
Yeah.
So we are going to name y equals a. Okay, y equals a. Everyone got it?
Mhm.
So if y equaled a, right here, this equation, right here, would this not be x minus 3y equals 5? Yes? And what's y equal?
Okay.
A. So I would add this 3y over on both sides, yes? So I have x equals 5 plus 3a. So this is what x equals, and this is what y equals. So my ordered pair is 5 plus 3a, comma, a. So what that does, we said there's infinitely many solutions, yes?
Yeah.
This is a dependent solution. It depends on what A is. Got it? So if A is 1, what is my ordered pair?
5 plus
3.
So 8, comma, 1. If A is
Oh,
6, what is my ordered pair?
6 times 3 plus 5.
6 times 3 is 18, plus 5 is
23.
23, comma,
6.
6. Do you see that?
Yeah.
Will it give us like if it's infinitely many? Will it give us A equals and then we
No,
figure
I'm
it out,
just
or do we-
showing. I'm just showing you that. So if it's infinitely many, this you have to take it that step and find that. Got it? That is why in before you had it, they said it was a dependent solution and gave you this. When we were doing 7-1, 7-2, I just wanted to know it was infinitely many. Now we're taking that extra step. Got it? Okay, a 3 by 3. So first thing I do is write a what? Augmented. You are to start this at the top of the page. You do 3 by 3s only at the top of the page. Do not start it anywhere else. Why?
Because it's gonna go.
It's gonna go long. Okay? Now if you start it at the top of the page and then you have to wrap it up to the next column, then that's one thing. But don't start it halfway down. Got it? Now I am going to have to wrap it around why?
Did you have like?
I have limited room, right?
So when we're doing our work and like we have a 2 by 2 or whatever and then a 3 by 3, can we like and we're like halfway done? Can we go out of order to get another
Yeah.
3 by 2?
Yeah, you could go out of order, but I think it goes 2 by 2s and then 3 by 3s.
Okay.
Okay, so your augmented should be, let me see, 1, -1, 2, and then -2, 3, -5, and 3, 3, 5, and 9, -4, 17. Yes?
Wait, wouldn't that one be?
Wait,
the
this
second
should
one
be a
0.
that should be 0. I had to stop.
I'm gonna say I was so
Yep, that's where I've written it and then stopped and looked. Why did I put it that 3 there when it should be a 0?
Because it's written wrong.
It's just written like that, right? So do I need to make sure before I move on that I have exactly what is there? Yes. Make sure your negatives are there. Guess what is the biggest thing people forget? The negatives. Don't come in and tell me, Mrs. Mick, I did this problem 6 times and I kept getting the wrong answer. And the first thing I do is go, that should have been -2. Okay, what do you do before you take your first step?
You double check.
You double check, because are you ever going to get the right answer? No. Okay, also hint, if you do get the wrong answer, do not try to erase it. Fold your paper over and start over. Because what happens if I erase it and start working over my other work, is my other work still there?
Yeah.
What are you going to do again?
You're going
You're going to make the same mistake. Even though you don't mean to, you're going to make the same mistake. Now, you could go try to find your mistake, that's fine. But if you just decide to start over, then just start over. Got it?
Row 1 plus row 2.
Okay, yes, but just a second. My first thing, I need to get these two to be 0, yes?
Yes.
And I'm going to use row 1 to do that. So I can do both of those rows at one time. Clear? Now we're only going to get this first step, but maybe 2, but we'll go for it. Okay, so am I going to change row 1?
No.
No, so I'm going to rewrite it. 1, -2, 3, 9. Yes? What am I going to do to get rid of this 1?
Multiply it. R1.
Combine.
Just
R1
combine
and
them. -1 and 1. Do I have to do anything else?
No.
No. So R1 plus R2. And don't do it yet. Just write down what you're going to do and decide what you're going to do on the next one. Keep your things together. Does that make sense?
Yeah.
Okay.
Row 1.
So I gotta get this 0.
So row
Negative 2.
one's
Negative 2 R1 plus R3.
Yeah.
And then you're going to do it. So do it. That was uncalled for.
When are
Did you get 1, 3, 5, -1, -1, -1? Okay. So I cleared column 1. I need to clear column 2. So what row do I use? Row? No.
Row 3.
What column?
Two.
2.
Row
What
2.
row do I use?
Two.
2. Now, if I could multiply something by a third or a seventh or whatever, can I do that anytime I want? Only do it if the whole row, though. Got it?
So then 1 and 2 don't change, right?
Nope. 1 and 2 aren't going to change. And what am I going to do just to get rid of that?
Add row 2
2
to row 3.
plus row 3.
Good luck, one act.
Good luck.
Okay? Remember, reduced row echelon form no matter what.